In this video, I am going to be discussing literal equations. So this is actually a term that was not very familiar to me, but a literal equation is an equation consisting of several letters or variables. Formula is a good example of a literal equation. So when you see a formula, you could look at that as a literal equation. What we're going to do here is we're going to solve for a specified variable. So that means, like in example 1, we have this formula. This is actually the area of a triangle. Right now, it's solved for A because the A is the one that's by itself, right? A is isolated or by itself on the left-hand side of the equal sign. But what they want us to do is solve for H. That means we want H to be the variable that's by itself and everything else on the other side. So that is the goal here, is to do that. This is important for several reasons. So one of the things that you will find yourself doing is solving equations. When you're solving an equation, you're going to be trying to get the variable by itself. So you'll be solving for often X. Other times you'll be trying to manipulate formulas or equations that you have to isolate a certain variable. And so you're going to be using this idea throughout your math courses. So for number 1, let's just try this. We're going to try to get H by itself. So the first thing I notice that's bothering me is that 2, right? The 2 in the denominator. So let me just rewrite this so I have room to work here. It's B times H divided by 2. So remember, to undo division, you should multiply. So to undo this divided by 2, I'm going to multiply both sides by 2. And what happens here, this is like 2 over 1, are the 2's divide out, right? Because 2 over 2 is 1. So this ends up giving me 2A is equal to BH. Remember, the whole goal is to get H by itself. So I need to move everything away from H. So I've moved to the 2. Now I need to move that B. So I have B times H. To undo multiplication, you divide, right? The inverse operation of multiply is divide. So we're going to divide both sides by B. B divided by B is 1. Right? So that's gone. And now I have 2A over B is equal to H. Notice that the H is by itself. So I'm now finished. If you like, you can change the side so that the H is on the left. Some people prefer that. But either way, you're done, right? H is equal to 2A over B. And that's it. Now, of course, this was a little more simple compared to some of the other ones you will see. So these could be complicated depending on the formula that you start with. But this is just a few examples to kind of get you started with the idea. Number 2, here the equation is solved for C because C is by itself. But we want to solve for Y. So we need to get the Y by itself. So we're trying to get everything away from Y. So we have AX plus BY equals C. When you're solving an equation, you undo addition and subtraction before you undo multiplication and division. So we have this AX that we need to get rid of first. So we will subtract AX from both sides of the equation. On the left-hand side, that will zero out because we have opposites. A positive AX minus AX will zero out and just leave us BY. And then on the right, we will have C minus AX. Those are not like terms, right? The C and the AX are not like terms, so we can't combine them. We're just going to write them in order, the C minus the AX. Next, again, we're trying to get the Y by itself. Keep in mind what you're trying to do. You're trying to get the Y by itself. So at this point, the only thing that's on that side with the Y is the B. This is multiplication, B times Y. To undo multiplication, we use division. You're going to need to divide the entire right-hand side by b. So the whole thing has to be in the numerator that was already over there, over b. A common mistake people will make is they'll just divide like one part by b. Okay, that is not correct. You have to divide both sides, that means the entire side, by whatever you're dividing by. So the b's will divide out to 1. B divided by b is 1, and we'll get y equals c minus ax all over b. Again, we have the y by itself. That's what we were trying to accomplish, and so we did that here.